Okay, coming back here with problem 19 of the fall term A review. And it says, find the slope of the line passing through the points -3, 7, and 2, 5. Okay, well, slope has a formula, and it looks like this. y2 minus y1 over x2 minus x1. And again, if you just decide this is point 1 and this is point 2, you've got x1, y1 right there, x2, y2 right there. You can plug them in and compute your slope. So 5 minus 7 on the top, that's y2 minus y1 over x2, which is 2 minus -3 on the bottom. Well, we've got this double negative thing going on here. I'm going to add the opposite of that. So I'm going to change that, and now 5 minus 7 is -2, 2 plus 3 is 5. And that's the slope through the points -3, 7 and 2, 5. Now we're going one level deeper here on this next one. We want to know slope-intercept form of the line passing through the point -3, 6 and parallel to the line y equals 3x plus 7. Well, first let's look at this. It's in y equals mx plus b form. So 3 is our m and 7 is our b. Now, a mistake a lot of students make in this type of problem is they just really need to find a home for that 7. And unfortunately, we're never going to use that 7, so you can just kind of ignore it. We are going to copy the slope because we want to be parallel. Now, we could have one of the two types of problems on the test. Whoa, that's a little crazy. Hold on. If we're talking about parallel, we want the same slope. If we're doing perpendicular, we want the negative reciprocal. Now, what does that mean? Well, since we want parallel, we're just going to use 3. What would we do if we wanted the negative reciprocal? Well, we're supposed to flip that over and then take the opposite sign. Well, it's kind of hard when it's just 3. So here's what you do. You put it 3 over 1, and then you flip it over, and then you make it negative. If it's negative, you make it positive. The slope and the negative reciprocal, when they multiply, should always multiply to -1. Now, of course, warning. None of that applies to this problem because we don't want perpendicular. We want to be parallel, which means we're going to do the same exact slope. So Rm is 3. Now we also need to use this point right here, -3, 6. The easiest thing to do would be put this into point slope form, which looks like this. Y minus y1 equals m times x minus x1. Okay, and guess what? There's my x1, y1. So let's plug that in. Y minus y1, which is 6, equals 3 times x minus -3. All right, well, there's that double negative cropping up again. We're going to add the opposite, so those turn into pluses. And then we got to distribute this 3, move this around, and we need to be in slope-intercept form, which means we need to be in this form right here. So let's see. 3 times x and 3 times 3, 3x plus 9, y minus 6 equals that, and then we're going to move that 6 over, plus 6, y equals 3x plus 15. Now let's take a look at that. Does it have the same slope? Is it parallel? Well, this one has slope of 3, and it looks to me like we have slope of 3, so that's a good thing. And then also it's supposed to be true for this point right here, -3, 6. So let's put that in there, and it better be true. -3 is x and 6 is y. So 6 equal to 3 times -3 plus 15. -9 plus 15 is 6. Yes, and it works. So happy math guy is happy. Determine if any of the following pairs of equations are perpendicular. Okay, well, I just talked about that a minute ago. We need to look at the slopes. If the slope of one is a whole number, then the other one should be a fraction with that number on the bottom. They've got to be opposite sign. One is always going to be positive and one is negative. Another example would be like this. 3 over 4, then the perpendicular slope's got to be negative 4 over 3. See, those two are perpendicular, these are perpendicular. Well, let's look. We got y equals negative x minus 7. That's actually negative 1x. So the m for this one is negative 1. Well, this one we're going to have to move around. I'm going to plus x, and I'll have y equals x plus 20. That's actually 1x. So the slope of this one is actually 1. Now this is a little tricky because it doesn't look that interesting. But remember what I said. If they multiply to negative 1, then they're perpendicular. And is negative 1 times 1 negative 1? Yes. These are perpendicular. All right, here. Now here we've got y equals 3 and x equals negative 2. These are kind of the exceptions to most of the rules because one of these has no slope and the other has undefined slope. So you're going to have to use your knowledge of what a y equals 3 line looks like and what an x equals negative 2 line looks like. Well, on your Cartesian coordinate system here, you're going to have to remember all your y equals lines go this way. Y equals 3 is right up there. That's y equals 3. All your x equals lines go this way, and that's approximately x equals negative 2. It's just a rough sketch. Whenever you have exactly one y equals and one x equals line, they are perpendicular, even though one is slope 0 and one is slope of undefined. Since one is perfectly horizontal and one is perfectly vertical, they will always be perpendicular right there. Now on to a more regular example here. Oh, let's see. Well, we'll just do the bottom one first here. First, I need to divide by 4 to get that y by itself, which means I divide all these by 4. Y equals negative 7 over 4x minus 2 over 4. You can clean that up to 1/2, but it's really irrelevant because we're not looking at that. We're only looking at the m value. Now, this top one, I'm going to move it over a little bit. There's my cursor. All right. 2x minus 7y equals negative 42. Going to subtract 2x to move that over. Negative 7y equals negative 2x minus 42. Divide by negative 7, all these times right here. Y equals, and you got a negative divided by a negative, that will turn into a positive. 2/7 x and 42 divided by 7, 6 plus 6. So the two things we're comparing are negative 7/4 and 2/7. And clearly they are not, one is not the other flipped over, but just to be sure, I will multiply them. Okay, and see if they end up being negative 1. 7 and 7 will cancel, and we'll have 1s there. Negative 1 times 2 is negative 2. 4 times 1 is 4. And we have negative 1/2, which is not negative 1. So these are not perpendicular, making math guy sad. All right, classify this triangle by its side length. This triangle right here has AC equal to BC. That's two sides equal. It is isosceles. And can you state the difference between a scalene, equilateral, and isosceles? Scalene has 3 unequal sides. Equilateral has 3 equal sides. And isosceles has 2 equal sides. Find the value of angle 1. Well, this is a thing called the exterior angle theorem, and the way it works is like this. This angle right here, angle 1, is equal to what they call these two remote angles. These are called remote interior. Angle 1 equals angle 2 plus angle 3. In our case, we've got angle 1 equals 80 plus 18 which is 98. All right, find the value of angle T. All right, to find the value of angle T, you've got to apply this thing called the triangle sum theorem, and it says that the angles of the triangle, the interior angles, always add up to 360 degrees. So angle T plus angle U plus angle V, whoa, hold the phone. 180 degrees, not 360. I misspoke there. They always add up to 180 degrees. Now, we can plug in the ones we know. We don't know what angle T is. Plus 58 plus 62 equals 180. That's angle T plus, let's see, 52 plus 8, 62 plus 8 is 70, plus 120 equals 180, minus 120 minus 120. Angle T equals 60. And you can go back and plug it in there and check and see, and it should add up to 180. 180, not 360. Find the value of, oh, there's the drawing way down there. Find X and T. Okay, well, what do we got going on here? Got a couple of right angles in here. We got a 45 right there. Says that angle's 3x. This side is 2t inches. Here's the big thing. Triangle ABC is congruent to triangle KLM. Aha, that's a pretty big piece of information. Well, that means that AB is equal to KL because of their positions in the congruent statements. AB should be equal to KL. And if we look, AB is 4 and KL is 2t. Well, that's pretty easy. Divide by 2, and t is 2. So we know what that is. But now, what are we going to do here? Well, angle A is congruent to angle K. It's a corresponding part. So 45 right there means this one will be 45 too. So this is 90 plus 45, and 3x should total to 180. 90 plus 45 plus 3x equals 180. And there might be some other shortcuts. You could do 3x plus 45 equals 90. Doing a little bit of the math ahead of time. You know, whatever works for you is fine. All right, 90 plus 45 is 135. Plus 3x equals 180. Minus 135. Minus 135. And 3x equals 45. Divide by 3, and x equals 15. I'm going to go back and double check. Even though I do remember it said find t and x, I like to make sure. Find the values of t and x. Because if it asks for the value of angle M, I don't want to quit too soon. There's our answers. We do not need to plug them back in. All right. Don't forget, we got our congruence theorems here. We've got side, 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 angle, angle, side, angle, 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 side, and hypotenuse, leg. I always like to write these together because these three do not skip a space when they're going around the triangle. And these ones down here do skip. So that helps me keep them straight. All right, looking right here. I've got angle 1, side 1, angle 2. Angle 1, side 1, angle 2. That looks like it is angle, side, angle. This one here, if you were to pull these apart, you'd see that this middle piece is shared. And it looks like it is side, angle, side. 1, 1, 2. That works. 1, 1, 2. Side, angle, side for these two. Now, this you got to be careful right here because a lot of people, as soon as they see the 90, they start thinking hypotenuse, leg all the way. But actually this one, they share this middle leg. So it's a leg, a 90, and a leg. Got to realize these two right here are a linear pair, so they are supplementary, which means this one's 92. So what you've got here is side, angle, side. So when you see a 90, it's a good indicator that you should think about hypotenuse, leg, but it's not guaranteed every time. All right, this one looks like side, side, side. Yes. Let's see. And this is why I put this